Hello everyone, my name is Ignacio and this is our presentation about the Nature Conservation Tank. We're part of a team of 5 students, including myself, Hazel, Cole, Roderick, and Emmanuel. And together we've been designing, building, and programming a robot that helps identify invasive plant species using artificial intelligence to protect our local ecosystems. And in the following slides, we'll be detailing you on how our project worked, step by step, so we can tell you what problems it solves and how we built it.
Our primary goal is to help reduce the spread of invasive species, particularly purple loosestrife, which damages native habitats along the rivers such as the Anacostia and Potomac. To do this, we created a robot that can patrol a designated area and detect the presence of this invasive plant. The robot uses a camera and artificial intelligence to recognize specific traits of purple loosestrife, helping conservationists target the problem more effectively. Our robot uses AI machine learning to analyze its surroundings, detect the plant based on color and shape, and determine the location. The PyTop system allows the robot to move autonomously and process visual data in real time. This project demonstrates how AI can be applied to environmental science to perform tasks like species identification more quickly and effectively than manual searching.
Our robot uses a search pattern to move, and what exactly is a search pattern? So a search pattern is a systematic way for the robot to move across an area so that it can thoroughly scan the environment. Think of it like mowing a lawn. You want to cover every spot without overlapping too much or missing anything. Search patterns are essential because they ensure that the robot efficiently explores the area for invasive species. In our search pattern, the robot moves in a grid made up of 1 meter by 1 meter squares. This path helps the robot cover small, detailed sections of land precisely. It's useful in areas with dense foliage or irregular terrain, where the robot needs to navigate carefully and make sure it scans each section before moving to the next.
For color detection, the first method used was detecting the dominant color in the images taken by the robot. But there was one main issue that came up when searching for the dominant colors, and that would be that any image that the purple loosestrife was in the wild, it was surrounded by many other dominant colors, such as blue from the sky, green from the grass, or brown from the dirt, which made it a lot harder to differentiate from these colors. The second and final method that was used for the robot was, rather than finding the dominant color in these images, it would be more focusing on finding one specific color that would be unique to the environment. And in this case, we chose the purple loosestrife because it is purple and it's not normally found in the wild, which made it very unique and easy to detect while it's in the wild. And it would also allow us to differentiate the colors much more easily because it's the color purple.
After the robot filters out non-purple objects using a Manos code, our model can then use that information to detect whether it's actually looking at purple loosestrife with the object detection code. We trained an AI with images from the plant taken at different angles and distances to identify it in a variety of circumstances. The more examples we feed to it, the better the robot gets at identifying it. And our current model works better at close distances rather than further distances, which is something we're working to improve.
My role was to integrate all of the system mentioned earlier into the robot. This process came with a lot of challenges that I had to either face or realize that there was no way around them. This includes making the code for the search pattern run on the robot, which wasn't as challenging as some of the other parts, but getting it to run with taking a picture and then being able to have that picture translate into both identification softwares is really where we came into issues because of how the code was written for the other 2 systems, and this wasn't compatible with the PyTop, and the PyTop itself not having enough storage and RAM to be able to run those codes independently. As you can see, this is a video of a robot driving around with the search pattern mentioned before. Additionally, you can also see the images captured by the robot's camera that we want to be able to use those images in coordination with the identification software. However, we ran into problems mentioned before, such as exporting those images into the identification software.
To conclude, our project started with one main problem. How can we use technology to help detect and control invasive species such as purple loosestrife? We answered that question by creating a robot that used AI to search, detect, and report. Along the way, we ran into challenges like data limitations, accuracy issues, and technical bugs during integration. But we learned how to solve them as a team. We're proud of the progress we've made and excited to see how this technology can be used in the real world.